Hey guys, this video is going to be a quick introduction to theoretical versus experimental probability. So you're going to learn more about this in math class this year, but this is just going to be a quick intro so you have some exposure to this before you take the forward exam. So let's go ahead and start with something called theoretical probability. Theoretical probability is basically what should happen when you're given an event. Okay, so it's like, hey, what should happen? What are my chances of getting something on this spinner? What are my chances of getting a heads when I flip a coin? That's theoretical probability. It's what should happen. So if I flip a coin and I say, what's the probability of getting a heads on a coin? Well, there's two different sides, and I could get a heads one out of the two. So my theoretical probability of getting a heads is a half, or 50%. I've got a 50-50 shot of getting a heads on a coin. So if I look at the spinner over below, I might ask you, what's the theoretical probability of getting a red? And this is a way to abbreviate asking the probability, this letter P right here. So that stands for, what's the probability of getting a red on that spinner? So when I look at the spinner, I'm not actually spinning it, I'm just looking at it, and I see, hey, there's 3 red spots out of 4 total. So I've got 3 chances out of 4 to get a red on that spinner. That's the theoretical probability of getting a red. It's what should happen. So again, I didn't actually spin it. I might ask you, what's the probability of getting a blue on that spinner? Okay, so I see, hey, there's 1 chance for me to get a blue out of 4 total different things. So my chances of getting a blue are 1 out of every 4, or 25% of the time. That's theoretical probability. A way to kind of remember that is thinking, hey, theoretical, that means like in theory, what should happen. It's not what actually is going to happen. Just in theory, what are the odds of getting a blue? 1 out of every 4. So now let's move to experimental probability, and you can probably guess what this means. This is your results. So what actually happens when you do the experiment. Okay, so it's what actually happens. Okay, so I might tell you, hey, I spun this spinner over here. I spun it 12 times, okay? And when I spun it those 12 times, I kept track of what I got. Let's just say I got a red, a red, a red, then I got blue, blue, red, red, blue, red, red, blue, and a blue. Okay, so those are my results. I want to know, I might ask you a question, what is the probability, the experimental probability of me getting a red? Okay, so this time I don't even really need to look at the spinner. Okay, I just want to know what actually happened when I did the experiment. Well, if I look up here, I see I got 1, 2, 3, 4, 5, 6, 7 reds out of the 12 times I did the experiment. That is the experimental probability of getting a red. So it's what actually happened when I did the experiment. If I asked you what was the probability of getting a blue in the experiment, again, I just look at my blues. I see 1, 2, 3, 4, 5. I got 5 blues out of the 12 times I spun. So that is my experimental probability of getting a blue. Notice that these two probabilities, like he showed you guys in the video yesterday, they should add up to 100%. So 7 plus 5 is 12 out of 12, or 100%. Okay, so let's look at another one. So let's say I have this bag of marbles here. Okay, I've got some green, I've got some red, got some yellow, and let's say I drew out of that bag 8 times. Okay, so I just drew 8 times, and every time I put the marble back. Let's say that here were my results. I got a red, then a yellow, a red, blue, I got yellow, then I got red, green, and green one more time. So that's what happened when I got the experiment. I might ask you, hey, what was the experimental probability of me getting a green? Okay, so when I did the experiment, it looks like I got 2 greens out of, I drew 8 times, right? So 2 out of 8, I can simplify that. Divide by 2, I get 1. Divide by 2, I get 4. So I got a green 1/4 of the time when I drew out of that bag of marbles. If I wanted to change that to a decimal, again, I do 1 divided by 4. Hopefully this is one you actually know. 1/4 is a quarter, or 0.25, which is 25%. So that was the experimental probability of getting a green. So now let's do a quick comparison. So let's say that I have this spinner here, and I ask you, what's the theoretical probability of getting a red on that spinner? Okay, so if I just look at the spinner, theoretical is what should happen, or in theory. I look at the spinner, I see red is 1 out of the 3 different outcomes I could get. So the theoretical probability is 1/3. Now let's say I actually did the experiment. I did it 9 times, and I got a blue, and then a red, yellow, red, and then a yellow. Okay, and now I asked you, what's the experimental probability of getting a red? Okay, so I actually did the experiment. Those are what I got. So I'm going to look at my experiment and see, well, how many times did I actually get a red? I got it 1, 2, 3, 4, 5 out of my 9 spins. So my experimental probability is 5/9. Okay, now if you wanted to compare those, let's just change those to fractions and decimals. So 1/3, hopefully you know that already. The repeating decimal for that is 0.3 repeating, or about 33.3 repeating percent. Okay, 5/9. You might not know that one, so I'm going to do 5 divided by 9. I get 0.5555 repeating, or about 55.5 repeating percent. Okay, so if you're just looking at this spinner, I would expect to get a red about 1/3 of the time, 1 out of every 3, or about 33% of the time. Now, when I actually did this, I got a red 5 out of 9, or 55% of the time. So I actually got red a lot more than I would have expected. Not a ton more, but you know, from 33 to 55, that is more. I got it more than I expected to get it. So that's the difference between theoretical and experimental. Theoretical is what should happen, or what you expect to happen, and experimental is what actually does happen. All right, let's do one more quick example. So I have a letter, or a bag of letters here, that I am going to be drawing out of. So first thing, if I just look at that bag of letters, I might ask you, what's the theoretical probability of drawing a bee out of there? So if I look at that bag, I see there are 3 bees out of 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So the theoretical probability of getting a bee when I draw in there is 3 out of every 9. Or if I simplify that, I divide by 3, I get 1. Divide by 3, I get 3. It's 1/3 of the time. If I change that to a decimal, it's 0.3 repeating, which is about 33 1/3%. Okay, now I actually did the experiment 9 times, and here's what I got. So if you look at this, I got an A, B, C, B, B, and C. So I might ask you, what was the probability, my experimental probability of getting a B? So if I look at it, I got B's 4 times out of, I did the experiment 3, 6, 9 total times I did. And I got a B 4 out of the 9 times. Okay, if I divide that out, I end up with about 0.44 repeating, or about 44.4% of the time. So it looks like I got B's a little bit more than I would have expected. So the last thing I want to quickly show you is making predictions with probability. So I have this spinner here, and I might want to try to predict how many times I'm going to get the letter A when I spin it a certain amount of times. So the first thing I'm just going to look at is, if I look at the letter A, I see there are 3 favorable outcomes. Like I could get an A 3 times on the spinner out of, looks like there's 8 total sections. So the theoretical probability that I get an A is 3 out of every 8 I would get an A. Now, I might ask you, what if I spun this spinner? We'll just say I spun it 40 times. Okay, I'm going to spin this 40 times. I want to know, well, how many times do you expect that I would get the letter A if I spun it 40 times? So I want you to pause the video and just think about, how could you solve this? Because there are more than one way to solve this. All right, so one way that you could do it is, I could say, hey, I'm going to get A 3 out of every 8 times. I can set up a proportion and say, hey, not out of every 8. What if I said, how many times would I get it out of 40? How many A's would I get? Okay. Now, a couple ways you could solve this. You could cross multiply and divide, which we did with percents this year. Or you could say, well, from 8 to 40, that's times 5. I'm spinning it 5 times as many times, so I should get the letter A 5 times as many times. 3 times 5 is 15. So I would expect to get the letter A 15 out of 40 if I spun it 40 times. Now, some of you maybe just said, well, okay, let's do 40 divided by 8, which is 5, and then you did times 3, which is 15. That could also work as well. So I just wanted to show you that quickly. So then just as a reminder, this was just a quick intro video on probability, theoretical and experimental. We don't expect you to be experts, but we wanted to preview this topic for you so you have a little bit of background information on it.